It's resolved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.
Welcome students to S. Chand Academy, the official YouTube channel of S. Chand Publications. The book Mathematics for IIT-JEE Mains and Advanced by M.L. Khanna sir and the videos by me, Subuh Nadeem. Now let us see the chapter which we have to do today is determinants. The earlier chapter which we discussed were binomial theorem. So this determinant is chapter number 10 of volume 1. Some of the basic concepts of determinant. First we will deal with that. So if we take a determinant like this of order 2 cross 2, then the value of this determinant is given as AD minus BC. This is how we get the value of a determinant of 2 cross 2. I am not going into the derivative of this determinant and what its physical significance. I am giving you an overall idea. If the determinant is A11, A12, A13, B12, B22, B33, C12, C22, C33, 3 ordered determinant. Then how can this be expanded? A11 and eliminate this row and column. So B22, C33 minus B33, sorry, this was C1, yeah, B33 into C22. And then let us come to A12 minus A12 and then B12 into C33 minus C12 into B33. Then this third element of the first row, A13. Then we eliminate this row and this column, B12, C22 minus C12, B22. So this is how we calculate by expanding in the first row. Now what are the minors and cofactors of a determinant? So if I take A1, A2, A3, B1, B2, B3, C1, C2, C3 like this, more simple way of taking a determinant rather than we took earlier. So here the minors are by taking any element and eliminating its row and column, the remaining element form a 2 cross 2 determinant, the value of which will be the minor. For example, B1. What is the minor of B1? So let us call it as capital B1. This is the minor of small b1. Then what is the minor? We eliminate this column, we eliminate this row, we get A2 C3 minus C2 A3. Now what is its cofactor? Cofactor also take into account the position of the element whose minor is taken. So this position is second row first column, which is 2 plus 1 3, which is an odd number. In that case the cofactor of B1 will be minus 1 to the power 3 into A2 C3 minus C2 A3, which will be minus, of course, cube of a minus is minus. If I take C2 and talk about the minor of C2, then minor of C2 is obtained by eliminating this row and this column, A1 B3 minus B1 A3. And if talk about cofactor, so cofactor of C2 is equal to, now its position is third row second column, 3 plus 2 5. So minus 1 to the power 5 into C2, the minor of C2. Let us take A3. So when we take A3, so minor of A3 is equal to, eliminate this row and this column, B1 C2 minus B2 C1. And cofactor, so its position is first row third column, 1 plus 3 4. So it will be plus, because minus 1 to the power 4 is plus 1 into A3. So this is how minor and cofactor are obtained. So if we take any row or any column and multiply them with the corresponding cofactors, we get the value of the determinant. Okay, so determinant value can be obtained. This value is written as delta. For example, we take first row, A1 into its cofactor plus A2 into its cofactor. I am taking dash so that you won't get confused with the minor. A2 and its cofactor and A3 and its cofactor. This will be the value of the determinant. But in case if you take a particular row and multiply it with the corresponding elements of the cofactors of the corresponding any other row, then the value of the resultant will be 0. For example, if you multiply A1 with B1 dash, B2 with B2 dash, this is not B2, this is A2, plus A3 into B3 dash, that will give you 0. That means you are taking the element of the first row and multiplying it with the cofactors of the element of the second row, then that will give you 0. This is an important property. Now, properties of determinant. What are the properties? First property is when you interchange row and column, so there will be a minus sign which will come. There will be extra minus sign. If you interchange row and column, there will be a minus sign. Second property is interchange rows. For interchanging row and column, there is no minus sign. Sorry. For interchanging row and column, there is no minus sign. If you interchange rows and columns, then the value of the determinant remains same. But if you interchange rows among themselves or columns among themselves, then there will be a one minus sign. So if you interchange two rows or two columns, then there will be a minus sign which will come. Third property, if two rows are identical or two columns are identical rows or identical columns, then in that case what will happen? The value of the determinant will be 0. So you don't have to calculate the determinant, don't expand it either with the first row, first column, second row, second column, third row or third column. You just see that two rows are identical, then the value of determinant is 0. Two columns are identical, then the value of determinant is 0. Other properties where if we interchange rows and columns, there will be no change in the value of determinant. And if we interchange two rows or two columns among themselves, then there will be a minus sign which will come. If we multiply a determinant by a scalar, then what will happen? So when we multiply by a scalar, any particular row or any particular column can be multiplied that scalar. For example, k delta. So what will happen? K A1, K A2, K A3. K is multiplied to the first row. It can multiply to second also, and other will remain as it is. B1, B2, B3, C1, C2, C3. Next property is sum of two determinants. How do we do that? So if we have A1 plus K, A2 plus E, A3 plus F, and B1, B2, B3, C1, C2, C3. So this can be written as A1, A2, A3, B1, B2, B3, C1, C2, C3 plus other element of the first row which got added was KEF. So KEF, B1, B2, B3, C1, C2, C3. This is how we do addition in determinants. Next important property is row or column operation. So when we do row or column operation, what happens? That, for example, A1, A2, A3, B1, B2, B3, C1, C2, C3 is given, and we are writing it as row 1 as row 1 plus k times row 2 plus L times row 3. Then the value of determinant will not change. So we can say that A1 plus k times B1 plus L times C1. Similarly, A2 plus k times B2 plus L times C2. Similarly, A3 plus k times B3 plus L times C3, and B1, B2, B3, C1, C2, C3. So the value of determinant will not change. This is a column operation. Similarly, you can do row operation. This is a row operation. Similarly, you can do column operation also. Multiplication of two determinants. Two determinants can be multiplied row to row, row to column, column to row, or column to column. But generally we multiply row to column to maintain a symmetry everywhere. But it can be row to row, column to row, row to column, column to column. Application of determinant. So what is the application of determinant? If we have a system of equations a1x plus a2y plus a3z is equal to d1, b1x plus b2y plus b3z is equal to d2, c1x plus c2y plus c3z is equal to d3. Then we find its delta, delta 1, delta 2, delta 3, that you can just see from the book also, that what is delta, delta 1, delta 2, delta 3. If delta is not equal to 0, then there is unique solution. Whereas if delta is equal to 0 and delta 1, delta 2, delta 3 are also all equal to 0, then infinite solution. And if at least one of delta 1, delta 2, delta 3 is non-zero, then we have no solution. And how do we obtain the unique solution? Unique solution is x is equal to delta 1 by delta, y is equal to delta 2 by delta, and z is equal to delta 3 by delta. Now let us see few questions on determinants. Evaluate. So problem set 1, question number 6a, you have to evaluate this circular determinant. So how will we do that? Here it is not so difficult if we remember the properties. We will apply column operation. Column 1 is column 1 plus column 2 plus column 3. So this will become a minus b plus b minus c plus c minus a. Then here b minus c, here c minus a. In the second row, first column, b minus c, c minus a minus b, c minus a minus b. And here c minus a plus a minus b plus b minus c, here a minus b, b minus c. Now we observe that b and minus b, c and minus c, a and minus a get cancelled. Here also the same situation. and here also they are getting cancelled. So it becomes 0, B minus C, C minus A, 0, C minus A minus B, 0, A minus B, B minus C. And do we need to find the value? You can just say that this is 0, the value is 0. Why? Because if you expand about the first column, all the elements are 0. When multiplied with cofactor, finally it will be 0. So you will say that this is 0. And you can add this also as a property, that if a row or a column have all the elements are 0 of a determinant, then that determinant is 0. Here you can write, since first column all elements are 0. Now next question we have, problem set 1, question number 32. If this determinant is equal to x plus iy, then find the value of x and y. So here we can do the expansion. There is not difficulty in doing expansion here. So when we expand it, 6i, and we eliminate this row column, 3i into I minus 3 into minus 1, then minus of minus 3i, that is plus 3i, why minus? Because this is first row second column 3. So minus 1 to the power 3 is minus. So minus of minus 3i plus 3i, 4i minus minus plus 20. Lastly 1 and 4 into 3 minus 20 into 3i. So this will become 6i, 3i square will be minus 3, this will be plus 3, plus 3i, this will be 4i plus 20, this is plus 12 minus 60i. First this becomes 0, so this is 0, 3i into 4i will be minus 12, 20 into 3y will be 60i, and from there it is plus 12 minus 60i. So as you can see, minus 12 and 12 cancels, 60i and minus 60i cancels, you get 0. Now this is equal to x plus iota y. Now do complex numbers are equal if their corresponding real part is 0 is same and corresponding imaginary part is same. So real part is 0 here, imaginary part is also 0. So x is 0, y is also 0. Now problem set 2, question 16a. This is a 4 order determinant and you have to prove that it is equal to x minus 1 to the power 6. So just see how we will calculate, so that we use properties. So first of all, I am using the property that row 1 is row 1 minus row 2. That will give you x cube minus x square. So x square will be common, x minus 1. Here when you will subtract, you will get x square minus 2x. So x square, 2x square minus 2x. 2 is common, x is common, x minus 2. Here you will get x minus 1. It is x minus 1 here also, as 2 is taken as common. Here it is x minus 1. And last will be 0. Like this. Now I am doing R2 as R2 minus R3. So this will be x square minus x common, x minus 1. Here x square, 2x will cancel, x square minus 1. Here x minus 1 and then 0. Here x minus 1, 2x minus 2. So 2 common, x minus 1, x minus 1, 0. 1, 3, 3, 1. So this is R3 as R3 minus R4. Now you can take x minus 1 common from the first row, second row, third row. So this will become x minus 1 to the power 3. And because a scalar when taken out of a particular row, it comes out of the determinant. So from the first row, this is scalar x minus 1 is taken, from second row and third row. And then we have 0, 0, 0 here. So if we expand about this fourth row, fourth column element 1, because all other are 0 basically here. So 0 with cofactor 0, 0 with cofactor, then also 0, 0 cofactor 0, 1 with this. So you'll get a determinant which is x square 2x 1, and here x plus 1 1, here 1 2 1, like this. Now again, can we apply some property? So let us see if we could apply. So this is equal to x minus 1 to the power 3. So again let us use this, we used here. Now let us use here again R1 as R1 minus R2 and R2 as R2 minus R3. So what will happen? X into x minus 1 this will become, here x minus 1 it will become, here it will be 0. Here x minus 1 it will become, here x minus 1 it will become, here 0, and here it is 1 2 1. Again you can take x minus 1 from the first row and x minus 1 from the second row. So it will become x minus 1 whole square, and x minus 1 to the power 3 was already there. So this will be x minus 1 to the power 5. Determinant of x 1 0, and then we have 1 1 0, and then we have 1 2 1. Now let us expand about this element, this column 0 0 and 1. So after expanding with 1, x minus 1. So x minus 1 to the power 5 into x minus 1, that will be x minus 1 to the power 6. That will be your answer, which we have to actually prove. Now we have the next question, problem set 3, question number 18. This is a determinant and we have to expand it to show that this is equal to this. Now expansion is a tough task for this determinant, and finding this value is really tough. So again we will use properties. So using property, of course we have to do this. Most of the question of determinant expansion and finding the value of determinant or proving, we have to use by property, 90% of the cases. So if you like, subscribe the channel and share with others. Also hit the bell notification to get the notification about the new videos. Here x square, y square, z square, and let us write column 1 as column 1 minus column 2. So x square will get cancelled, here y square will cancel, z square will cancel, and further minus 2 times of column 3. So when you expand y minus z whole square, y square plus z square minus 2yz into minus is plus 2yz, and minus 2yz will be 0. So this will be C1, C2 as C2 minus C1 minus 2 C3. So C2 minus C1, so minus y square minus z square minus 2 C3 minus z square minus x square minus x square minus y square. And this will be yz, zx, xy. So this is how we have simplified it now. Now in the next step, what we can do, first we take minus outside from the second column. Minus 1 is a scalar, it will come outside. And also do one thing, column 2 as column 2 plus column 1. So x square, and this will become y square plus z square plus x square. This will be y square, z square plus x square plus y square. This will be z square, x square plus y square plus z square. And this is yz, zx, xy determinant. So this will be minus 1. Now we can take common x square plus y square plus z square from the second column. X square plus y square plus z square from the second column. And there is one such term. So at least we are on the right path. This is x square 1 yz, y square 1 zx, z square 1 xy. Okay. Now this is equal to minus x square plus y square plus z square. Now this determinant we have to find out. How can we find it out? So again let us see what is going on in the RHS. Similar to that we should have our approach. So let us do rho 1 minus rho 2 and rho 2 minus rho 3. So when we do rho 1 as rho 1 minus rho 2 and rho 2 as rho 2 minus rho 3. So this will be x square minus y square. So x square minus y square 0 and z x minus y. Then y square minus z square 0 and x common z minus y. Lastly z square 1 xy. Now from the first row x minus y will come outside. From the second row y minus z will come outside. It is y minus x. Sorry. It is y minus x. So, and here it is z minus y. Right. So this will be minus x square plus y square plus z square into x minus y from the first row, y minus z from the second row. This will become x plus y 0 and minus z, because you are taking x minus y, not minus x plus y. This is y plus z 0 minus x, and this is z square 1 xy. Now we can expand about this second column. So this is 0, this is 0, 1 is only there. So minus x square plus y square plus z square, x minus y, y minus z into, this will be second row, third row, second column 5. So minus 1 to the power 5 minus, so minus minus will be actually plus, right? Here it will be plus. If you take minus outside, minus 1 to the power 5, minus will be absorbed, and then you have x plus y into minus x, that will be minus x square. That will be, sorry, minus x square minus xy plus zy plus z square. Now here you can further simplify and you can write y minus x minus y minus z was there, you need z minus x. So z you will get from here and minus x from here. So x minus y, y minus z, z minus x into x square plus y square plus z square, and z minus x, so z plus y, z plus y is there, as you have taken z common, and minus y is also common, so plus x. Yeah, right. Z minus x from here, so you get y, and z minus x from here, so you get z plus x. Okay. So finally, we have proved this statement. So there are a lot of manipulations which you have to do. If y is equal to sine px, prove that delta is equal to this, where yr means Rth differential coefficient of y. So this is y, this is its first derivative, this is second derivative, similarly third, fourth, fifth, sixth, seventh, eighth derivative are there. And what is y? Y is sine px. So delta is equal to y, which is sine px, derivative of y, first derivative p cos px, second derivative minus p square sin px, then its derivative minus p cube cos px, then its derivative p to the power 4 sin px, then its derivative is p to the power 5 cos px, then its derivative is p to the power 6 minus sin px, then its derivative is minus p to the power 7 cos px, then its derivative is p to the power 8 sin px, right? Now you have to find its value, and which should be equal to 0. So you write it equal to what can you take common as is from the second column p is coming out, and from the third column p square is coming out. So p cube will come out finally, and determinant of sin px cos px minus sin px, and then minus p cube cos px p cube sin px, and then p square p cube cos px. Then we have minus p to the power 6 sin px. So p cube is taken common, minus p cube sin px. Here p you have taken common, minus p to the power 6 cos px. Here you have taken p square common, p to the power 6 sin px. Now here again, when you observe, this first column and this third column are having only difference of minus 1 with each of its term multiplied to it. So you can take that minus common, and you can take it minus here. This will plus minus minus. Now the first column and the third column are identical, and we know if two columns are identical or two rows are identical, then value of the determinant is 0. So this is p cube into 0, which equal to 0, proved. So you can use the property that the first column, first and third column are identical. Let us come to the next question. Problem set 2, question number 34. Fx is x minus a, x minus b, x minus c, x minus d, then prove that delta is equal to this determinant 4 cross 4 is fx minus x f dash x. So what is x f dash x? F dash x, if we are talking about, it is actually nothing but the product rule of derivative will give you x minus a, x minus b, x minus c, plus next we don't have x minus a but x minus b, x minus c, x minus d. Next we don't have b, we have x minus a, x minus c, x minus d. Lastly we don't have x minus c, x minus a, x minus b, x minus d. So this is what we mean by f dash of x here, by product rule of derivative of a multiple of various functions. 4 functions are there. Now delta is equal to, if we apply the row operation, r1 is r1 minus r2, then we get a minus x, x minus b, 0, 0, then r2 as r2 minus r3, then 0, b minus x, x minus c, 0, then r3 as r3 minus r4, then we have 0, 0, c minus x, x minus d, then we have x, 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 d. Now here let us expand along the first row. So what will happen? A minus x and this particular determinant. And if we expand this particular determinant, it will be b minus x, c minus x into d, and then minus x minus c, and this is 0, minus x into x minus d. So x into x minus d, like this. Next is x minus b, so minus x minus b, and this is eliminated. Then this 3 will form the 3 order determinant. About x, it will be x minus c, x minus d, minus x. So this is eliminated, this, and this is c minus x into 0. So this will be 0. So what will happen? Some of the calculations you have to do mentally also, because there won't be much space in the question paper or answer sheet, and also time is not permitting you to do much of the calculation on paper. So I have done most of the calculation mentally. Now this is a minus x, b minus x, c minus x, which I can write x minus a, x minus b, x minus c, it's the minus sign into d. Another one is x into x minus a, x minus c, x minus d with a minus sign. So there is a minus here. Then we have minus of x, x minus b, x minus c, x minus d. Then we have, that is it. This is 0. So this is, now let us add x into x minus a, x minus b, x minus c here, x into x minus a, x minus b, x minus c here, and subtract x into x minus a, x minus b, x minus c here. One more term should have come. Let me see, x minus b was there, right? And when it was eliminated, then x was remaining like this, and x minus c, x minus d minus c minus x into 0. There should be 4 terms, right? Because this will give you x minus a, x minus b, x minus c into x minus d minus x, f dash x, c a d is there, b c d is there, a b c there, and a b d should also be there. So a b d, how will you get it? Let us see calculation once more. A minus x, x minus b, 0, 0, 0, b minus x, x minus c, 0, 0, 0, c minus x, x minus d, x, x, x d. Fine. Next, a minus x, then this is eliminated. About this, b minus x, c minus x into d, okay, minus x into x minus d, okay, this one term we missed. So plus b minus x, c minus x into d we did, minus x into x minus d, so minus x into x minus d. Further, we did x minus c, the minus sign, and minus x, x minus d. Yeah, that is fine. So this one term we missed. So that one term will go there. It will become minus x, b minus x, x minus b, x minus a, x minus b, x minus b, x minus d. Yeah. So while calculating, there may be possibility of some miscalculation while doing mentally, but you can finally find out the error. So now these 4 terms are actually minus x into f dash of x. As we know what is f dash of x, there are 4 terms like this. One ACD, BCD, ABC, ABD. And this term, x minus d is taken as common. So this will become x minus a, x minus b, x minus c, x minus d. And this is nothing but fx. So fx minus x f dash x. This is what we have on right hand side. Proved. If ABC are all different and the equations are consistent, then prove that ABC plus 1 equal to 0. So here it is 3 equations in 2 variables, not 3 variables. No z is there. Be quite attentive while seeing this equations. Be cautious. So it is not the case of Kramer's rule. Be cautious. So here there are 2 variables x and y, which means there is a straight line in the coordinate plane. And how many straight lines? 3 straight lines. And if they are consistent, it means that 3 straight lines passing through a particular point, which is the point of intersection, that is the solution of this set of 3 straight lines. So 3 straight lines are concurrent. So what they are saying that these are concurrent lines, not Kramer's rule. Then in that situation we know coefficient of x, then coefficient of y, and then constant. That determinant should be equal to 0. Then we have to prove that ABC plus 1 equal to 0. So from here, let us take row operation. So R1 is R1 minus R2. R2 is R2 minus R3. So this will become A minus B. This will become B minus C. C. This is A minus B into A plus B. This is B minus C into B plus C. This is C square. This is A cube minus B cube. That will become A minus B, A square plus B square plus AB. This will be B cube minus C cube. So B minus C, B square plus C square plus BC. This is C cube plus 1. So in the next step, you can take A minus B common from the first row and B minus C from the second row. So A minus B into B minus C, and what will remain is 1 A plus B, A square plus B square plus AB, and here 1 B plus C and B square plus C square plus BC, and from here C square C cube plus 1. This is 0. Now A, B, C are all distinct. So A minus B cannot be 0, B minus C can also not be 0. So what will happen? That this determinant is 0. Now if we take this determinant, again we apply the operation R1 as R1 minus R2. So this will become 0, A minus C, and this will become B square cancel, A minus C into A plus C plus B, and here 1 C, C square B plus C, and this is B square plus C square plus BC. This is C cube plus 1. So this determinant. So in the next step, again you take C minus A common and expand it. So this is equal to 0. So when you will expand, this is actually expansion of 0, C minus A taken as A minus C common, 1, A plus B plus C, 1 B plus C, this is 0, B square plus C square plus BC, C square C cube plus 1. So here when we expand, say about the first column, this is 0, this is 1. So this will be c cube plus 1 with a minus sign overall minus ac square minus bc square minus c cube. And then for c, b square plus c square plus bc minus b plus c into b plus a plus c is equal to 0. Now here c cube will get cancelled, and when you will further proceed, many terms will get cancelled and you will finally get abc plus 1 is equal to 0. There is not enough space to calculate further, so I am leaving it to you. When you will multiply here, many terms will cancel, like b square will cancel, c square will cancel, bc will cancel, and what will remain? Let me try to do it for you in whatever space we have. So minus 1 plus ac square plus bc square. Then from here b square, c square will cancel, bc will cancel, 6 terms, 3 terms will remain, that is c into minus ba plus bc plus ac, right? Then when you will further calculate, minus abc minus 1, this will remain, and ac square and ac square, this will cancel, this is in minus, this is also in minus, bc square, so this will get cancelled, this is equal to 0, so abc plus 1 is equal to 0, right? Let us come to the next question. The value of this determinant is equal to, so let us apply R1 as R1 minus R2 and R2 as R2 minus R3. So this will become minus 2 minus 3 minus 4. This will become minus 4 minus 5 minus 6 x plus 7 x plus 10 x plus 14. Then again R1 as R1 minus R2. So this will become 2 2 2 minus 4 minus 5 minus 6 x plus 7 x plus 10 x plus 14. Now 2 is taken as common and we further apply R1 column 1 as column 1 minus column 2 and column 2 as column 2 minus column 3 after taking 2 common from the first row. So 1 minus 1 0 and minus 4 plus 5 1, 7 minus 10 minus 3. Here 1 minus 1 0, minus 5 plus 6 1, 10 minus 14 minus 4, 2 minus 6 x plus 14. This is equal to 2 into 2 minus 4 plus 3 minus 1, that is minus 4 finally. 2 into 2 minus 4 plus 1 3, okay, minus 4. So none of these. Next question says if omega is a cube root of unity, then a root of the following equation is. So here if you take omega as a cube root of unity, then this equal to 0 will give you the value of x. For that, let us do R1 as R1 plus R2 plus R3. So this will be x plus 1 plus omega square, and we know that 1 plus omega square is 0. This is x, this is x, this is x is equal to 0. So this fact is being used, omega x plus omega square 1, omega square 1, x plus omega, x taken common from the first row, x 1 1 1 omega x plus omega square 1, omega square 1, x plus omega 0. From here we get a solution x is equal to 0. So we should not worry about other solution because x equal to 0 is already one solution and it is a single correct option question. So x is equal to 0. Right? So let us see one more question, earlier one. Okay, this we did. So these are all questions for the day. Thank you, students. We'll meet you in the next session.